Yeah. So this is the last bit of kinematics. Projectile motion. It refers to a two-dimensional motion. Okay, we've been talking about straight line motion and horizontal line. Just maybe studied the kinematics equations and the distance, displacement, acceleration, everything. And then we also talked about vertical motion, falling freely and falling under the influence of air resistance and other resultant forces. This is basically where you combine horizontal and vertical now. A motion that has both the dimensions. So let's see, consider a car moving that is moving in a straight line. The motion of the car is one dimensional. Okay. Up, if this football is, for example, kicked, now this football, it follows a curved path, which is known as a parabola. Whenever a parabola is formed, it means that there are two vectors. One of the vectors is of horizontal velocity, and the other vector is of vertical velocity. इसी वजह से if you draw a vector, resultant vector, it goes in this direction. And this resultant vector sort of represents the final movement or the final direction of this football, right? इसी तरह
Yes.
से किसी भी at any point, if you're drawing this horizontal, vertical, अब इसमें तो ये थोड़ा सा डिफरेंट हो जाएंगे, इसमें ये आ जाएगा, सॉरी, vertical, और फिर this is your resultant vector. Similarly, यहाँ पे सिर्फ horizontal है, this itself becomes the resultant vector. तो कहने का मकसद ये है कि यहाँ पे आपको ये पता होना चाहिए कि कहाँ पे there's horizontal motion, where's this vertical, and where there's a resultant. The resultant vector sort of tells you direction of movement. Projectile motion, the two-dimensional motion illustrated is called projectile. The curve traced out by the object subject to a constant force in one direction is a parabola. The projectile motion of a particle can be studied by splitting the motion into horizontal and vertical components. हमने ये बात की है सारी, and considering the forces that move the object separately. Figure 2 explains a scenario where projectile motion happens. अब इसमें अगर आप देखें तो there's this part where the object is sort of thrown from, ठीक है? And if you release it from this point, the object um, follows this curved path and this is where it lands. अच्छा, अगर हम ये देखें, let's say, imagine if the object only had a horizontal force. Horizontal force was basically the push of this cannon. यहाँ से वो push हुआ है. Or there's no way, there's no vertical force. The object would, in an ideal situation, continue moving in a straight line on this dotted path. Whereas if you imagine the object to just have a vertical force, the weight, and no horizontal force, no additional push, the object would have fallen down in a vertical straight line following that path, motion due to gravity alone. But in reality, because there's motion due to the horizontal force and motion due to gravity, it follows this blue path, which is a curved actual motion. And at every instant, it is going to have a vector for a horizontal velocity, a vector for a vertical force. Horizontal force, vertical force. Horizontal and vertical. And this is why the, what do you say, the resultant would be in a straight line like this, in between. And this resultant refers to the direction of motion in reality.
Yeah.
Okay. Okay. Now, the governing equation for projectile motion. If a particle projected with velocity u, yaad rahe, this is velocity, angle theta to the horizontal from a point on level ground, the range is defined as the distance from the point of projection to the point at which the particle reaches the ground again. The range can be calculated using this formula, u square sine 2 theta divided by z. अब यहाँ पे आपके पास ये जो सारी चीजें हैं, ये basically this imagine अगर आप if you're kicking the football at this point, um, this is u, your initial velocity. यहाँ पे थीटा क्या है, एंगल है जो इस वेक्टर के साथ बन रहा है, एंड देन r is basically the final range of motion. Initial position, final position के दरमियान का distance है, that is range. Let's apply this over here. If let's say a ball is thrown from the top of building 45 meters high above the ground level with an initial velocity of 15 meter per second in a horizontal direction. How long does it take to reach the ground? How far from the base of the building is it when it reaches the ground? तो यहाँ पे 80 meters is the height और this is how the ball is thrown. अब इसका मतलब ये है कि ball will travel how much? यहाँ पे 45 meters high above the wait ये कोई और मुझे लग रहा है कि डायग्राम इसकी कुछ और है. दिस इज बेसिकली सोल्यूशन. ये देखते हैं कि यहाँ पे 45 meters high above the ground level. इसका मतलब ये है कि the ball needs to travel 45 meters downwards to reach the ground level. The vertical component of the motion is governed by the equation. अब you're going to be using the kinematics equation as well. If you want to understand what is the vertical velocity, the initial, तो आप you're going to use ut plus half at square. अब ut plus half at square में if you plug in all of these things, आपको you get a displacement of 120 meters. ठीक है. This 120 meters के displacement का मतलब ये है कि this is how much you displaced horizontally on the ground. ठीक है. और इसमें
ठीक
आपको इनिशियल वेलोसिटी आपको मिल रही है u which is 30 मीटर पर सेकंड की at the point when you're starting this will be initial velocity. Acceleration 9.8 हम इमेजिन कर रहे हैं इसमें. ठीक है. So projectile motion, abhi we're going to get to the questions. Aapne iski, you'll understand this in a better way. But projectile motion is basically a motion that forms a parabola, and it can be analyzed in forms of two independent motions at right angles: the horizontal component, the vertical component, and then there is a constant acceleration due to gravity. The range r is defined as the distance between the file and the initial positions of the projectile. All right.
ठीक
ठीक है. अब हम will move on to the questions.